Hi everyone, I'm Thomas and welcome to Software with Thomas, my new channel where I am going to be doing some live streaming once a week at this time, roughly every week. And I have a little solo gaming Sunday this week, Turing Machine edition, where I will be returning to one of my favorites, Turing Machine. Hopefully the stream is coming through okay. I've been having crazy technical issues today. I don't even know if the live stream is properly working. I don't know what's going on. I am so sick of tech issues. I thought I had it working and then I clicked go live and now I'm getting like some weird errors, and so I don't know if you're actually seeing this. Hopefully you are. Valid path. So you basically just need to choose an empty folder. So I have Godot opened here. You can see completely blank, clean canvas. So we're going to create a new project. We're going to browse to, I have a workspace, Godot, tutorials, first 2D game, and that's the folder we're using. And I'm just going to call it first 2D game. And create and edit. That should launch it. I guess it launched it on my other screen, but I'll drag the window back. Maybe if the window wants to drag. There we go. Make that nice and big, and we're looking good. So first step done. We're on our way to making this 2D game. So the next thing is this game is designed for portrait mode. So we need to at least adjust the size of the game window. And you do this by clicking on project and project settings. Then there's a display portion on the left-hand side with a Windows tab. You click on that and you can change the viewport width and height. So we need it to be 480 by 720. Okay, is this going to be annoying? Maybe I'll have to like tab between them. Seems like it's a little annoying about that. So, let's click on the project, and then it's up at the top. Duh. You can't see, but I have like my Mac bar at the top. There's project, and then you can click on project settings. That opens this up. Window. I just noticed that now. Okay. Well, you know what it says to do now? It says to test it, and let's see if it works. So we click play scene up here. You can also, what does it say? You can do F6 or Command R on Mac to run this. No main scene has been selected. Let's just select current because that's what we're on. A little window pops up. Got to give it a second to load here. It's the first time it's loaded, so it seems like the first time you run this, it usually takes a second, even for a small 2D game. But you can see our player up there, and look at that. Left, right, up, down. And as we move, you can see the little walking animation going on. Now, it's not the correct animation, and that's something we're going to deal with here in a second. But hey, and if I try to move off the screen, you just can't. It lets you kind of partially move off the screen, but then it stops you. And that's the clamp function coming into play. So cool. We have a... right, and we almost have this next one set up. I just have to get 2 more cards out and we'll be rocking and rolling. So the first one went pretty well. It's been a while since I've played, so probably took me a bit more than I wanted. Let's go through it line by line. I'll quickly talk about it, paste it in, and I guess we'll be able to test the scene here in a second. See how it all is coming together so far, but we're almost there. We're just got to finish this, add the heads up display, and then a couple finishing touches, which are optional, but we're going to go through them anyway. So first, we got to create a new instance of the mob scene, which is just we have the mob scene variable. We're just calling instantiate on it. And we're choosing a random location along path 2D. So location is just the mob path divided by or / mob spawn location. And then the location is just, we take the progress ratio and do a random float value to get kind of a random location. The direction is we take the mob spawn location and we take the rotation of it and we add pi divided by 2. And that sets the direction perpendicular to the path direction. And this goes into a little bit more about pi at the bottom. We set its position by taking the mob spawn location and just taking the position. We add some randomness to the direction. So for the direction, which we create up here, we add a random float value between pi divided by 4 and pi over 4. And then mob.rotation just equals direction. And then finally, we set the velocity. So velocity is a vector 2, and we do a random float range between 150 and 250. And then that's just the one value, and then the other value for the vector is just 0. So finally, we just set the linear velocity to this .rotated, velocity.rotated with the direction we created, and then finally we bring it all together by adding child of mob. That's a lot of code. It's fine if you don't fully understand all of it. I'll be honest, some of it is definitely confusing. I'll read this important because it's important. Why pi? Well, in functions requiring angles, Godot uses radians, not degrees. So pi represents a half turn in radians, about 3.1415. There's also tau, which equals 2 times pi. If you're more comfortable with working with degrees, you need to use the degree to radians and radians to degree functions to convert between the two. So we're just gonna copy all this and add it in because I no reason to see me type that all slow here. So we go to the mob timer, the timeout signal, double click, click connect, adds that to our main function. Boom. And I guess my naming of mob timer is a little weird, but that's fine. It knows what I mean. And so we add that all in, and we're almost ready to test, it looks like, which I'm very curious to see. I hope this goes well. So let's test the scene to make sure everything's working. Add this new game call to ready. So we're just calling new game. Let's also assign main as our main scene, the one that automatically runs when the game launches. Click play and select main scene when prompted. If you already set another scene as the main scene, you can right click on main in the file and click set as main scene. So all we gotta do is add this under ready. And we're gonna be able to see how this is looking so far, which hopefully doesn't like crash. That'd be awkward. So I've been following this tutorial pretty good, I think. Oops, I wanted to save it. And then over here in the file structure, I'm going to find the main scene we've created, right click, and set as main scene, wherever the heck that is. There it is. So that's the main scene now. And now we click run and hope that stuff happens. Oh no, it did crash, no. Okay, I think I need to, it's because my mob timer function is just named weird. I had a capital I, so I think that's the case. I thought it wouldn't matter, but apparently it does. I hope that's the only issue and I don't have to troubleshoot right now. And look at that, we got mob spawning and, well, I already died. I'm not doing too good at my game. Let's retry that. I was trying to make the screen big before stuff starts happening. Okay, we can move around, the animation's good, and I died again. I suck at my own game. That's okay though. Seems to be working good so far. Yeah, a little bug there, but figured it out pretty quick. And we're moving right along. So what's our game lacking? Some user interface. So in the next section, we won't quite know yet. But what I want to test is 2, 4, 5. And I just want to test B and A. And then I think with that should be enough to solve. Because then D, I think we'll be able to figure out. We might not even need to test B. Let's just test A first. I want to know, and then it will kind of maybe work from there. And we do get a check mark that square is greater than 3. So we know square can't be 3, so we can kind of move this line down. So we know that square is either going to be 4 or 5. So now we're limiting our to the on score timer timeout to keep track, keep the display in sync with the changing score. So yeah, we just update the score whenever that runs. So on score timer timeout, the score gets incremented by 1, and then we update the HUD with the update score function that we just created, just like that. Remember to remove the call to new game from ready if you haven't done so already. Otherwise, your game will start automatically. Good call. I definitely still have that there. Glad I had that reminder. Now you're ready to play. Click play the project button. You'll be asked to select a main scene. Make sure to choose main. And let's see how our game is looking currently. Look at that. So we got a nice little main screen. It says dodge the creeps, shows our score. We got a start button. We click start. It says get ready. gives us a second, and then enemies start spawning in. And you can see the score is incrementing the longer we stay alive. Okay, I'm panicking here. And I got a score of 7. Not bad, 7 seconds is what I survived. And then you see after a second, main menu comes back up, and we can click start again. Our score will reset, get ready, and we can just repeat. I'll just die on purpose here. That was totally on purpose. And cool, we got a working game. We're real close. There's a few more things we gotta do though. The last part of this section is removing the old creeps, which is not too hard to do. So if you play until game over and then start a new game right away, the creeps from the previous game may still be on the screen. So it'd be better if they disappeared at the start of a new game. We just need a way to tell all mobs to remove themselves. We can do this with the group feature. So in the mob scene, you can select the root node, click the node tab, which is like where the signals are, but there's another button called groups. And then you can type in a group name and click add. So we're gonna just add in a new group called mobs. And then we can add this following line into the new game function that just says, we call group of mobs and we just call the queue free function, which just essentially removes them. So let's do that. So we go to the mob scene here, click on mob over here in the node tab. Instead of signals, we click up here on groups and we just add mobs. I'm pretty sure that's plural, right? I don't want to, that probably doesn't matter too much, but yeah, we'll add mobs there. We save that and then go back to main, and then our new game function, we just add in this little function here. So this gets the tree of all the different scenes, I guess. And we call this with the group, we call a function on the group of mobs, and the function is queue free, which should just remove them. Game's mostly done at this point, and the next and last part, we'll polish it a bit by adding a background looping music and adding some keyboard shortcuts. Let's see where we're at again. I'm gonna try to see if that is working now with it removing them. So I'll have to just try to end a game and start another one up really quick. Okay, I was trying to move with WASD. I can't even test it because the mobs are moving off the screen like at the perfect time. Because there's a bit of a delay, so I just can't even really test if it's working, but I think it is. I mean, it should be. Let's try this one more time. I need to die like close to the edge of the screen, so then I guess that wouldn't really matter, would it? The timer's just too long, so I can't even test if that last part works. Well, let's just assume it does. Because I've been following this tutorial pretty close. And we're on to the last step, finishing up. Completed function stuff as is, and I guess that's it. Let's see if that actually works. It'd be kind of crazy if it does. I mean, I don't know why it wouldn't, but I mean, maybe I made a typo. So I'm just gonna not click it. I'm just gonna click enter, and it starts. And that's it. That's the 2D tutorial for Dodge the Creeps in Godot. We're doing. Took a bit longer than I anticipated, but that's okay. That's totally fine. Yeah, that's the end of the tutorial. So you got to make a player-controlled character, enemies that spawn randomly around the board, count the score, implement a game over and replay, user interface, sounds, and more. Congratulations, but there's still much to learn. But you can take a moment to appreciate what you achieved. When you're ready, you can move on to your first 3D game turn to create a complete 3D game from scratch in Godot, which is what we're testing for. What is the sum of all the numbers? Is it odd? Is it even? So we have to do some quick math here. So was that 7? So that's odd. That's 8. So that's even. That's 10. So that's even. I'm gonna maybe slow down to make sure I don't mess up my math because that would be bad. That's 6, that's 8, so that's even. That's 4, that's 9, odd. That's 10, that's even. That's 9, so that's odd. What do we got here? 6, that's 11, so that's odd. That's 10, so that's even. We got 7, that's 11, so odd. And then we got, my brain's starting to melt a little bit. There we go. That's even because that's 12. And then finally 12 again. So even. Okay, great. Now, I like to think, okay, we pretty much, I guess some of that was off screen, my bad. At this point, we should just eliminate anything that has the same outcome. Because let's say if we were to ask B, let's say we know it's odd, we ask that, D, and we know it's, let's say, even, we got a lot of answers that are odd and even. And we, as you know in this game, you can only have one single solution, and all of these will point to one single solution. So having all of these kind of overlap in their answers is not really possible. So do we have double odds? We do. I'm just looking at what we don't have doubles of, because I think we have everything kind of overlaps. So sometimes this method does fall apart, and I think this might be one of those cases, but I don't actually, I take it back. I think we're good because double odds, so this cancels out with this. We have a lot of these odd evens, so any odd evens cancel out. Let me go through and eliminate all of those. Odd even, odd even, odd even, odd even. So now we just got these answers here, which is even odd, even odd, even odd, or even even. Whoa, there's only one that's different. 2, 5, 3. And that is my red arc to rotate around the x-axis until the ground is lit. And then we're also going to turn on shadow enabled by clicking the checkbox, and we should have something that looks like that. And that's our starting point. Okay, so let's finish this. So we're clicking on the, that's adding it to the main, right? Main, add light, and it was the directional light 3D. Make sure I'm adding the right one. Okay, and then move it up by dragging the green arrow. Great. And then the red arc to rotate the x-axis. So it's pointing down. And then we also need to go over here to shadow and click enable. Neat. It's really that simple, huh? Okay, we're done with the first chapter, the first step of the tutorial, whatever you want to call it. Setting up the game area is complete. So now we're on to player scene and input actions. So in the next 2 lessons, we will design the player scene, register custom input actions, and code the player movement. By the end, you'll have a playable character that moves in 8 different directions. We're gonna create a new scene by going to the scene menu at the top left, clicking new scene. And this will be adding a character body 3D node as the root. Way to name it player. Character bodies are complementary to the area and rigid bodies used in the 2D game tutorial. Like rigid bodies, they can move and collide with the environment, but instead of being controlled by physics engine, you dictate the movement. You will see how to use the node's unique feature when we code the jump and squash mechanic. For now, we're going to add basic rig for our character's 3D model. This will allow us to rotate the model later via code while it plays an animation. Okay, let's do the first part first. Maybe getting a little ahead of myself, so we do new scene. Other node, character body 3D, create. Name the character body 3D to player. Done. I guess that was it. So now we just need to add a node 3D node as the child of the player. Name it pivot. So let's go ahead and do that. So node 3D node, boom, and call it pivot. Great. Guess we'll figure out what that's gonna be for here in a second. Then in the file system doc, expand the art folder by double clicking it and drag and drop the player.glb onto pivot. This should instantiate the model as a child of pivot. You can rename it as character. Okay, that sounds pretty simple. Player over pivot. Whoa, that's crazy. And then what were we supposed to name it? Character. Right. Cool. We're moving right along. Oh, here's a nice note. The .glb file contains 3D scene data based on the open source GLTF 2.0 specification. They're a modern and powerful alternative to proprietary formats like FBX, which Godot also supports. To produce these files, we designed the model in Blender 3D and exported it to GLTF. Cool, that's great. I mean, I'm all for more open source stuff, less proprietary stuff. So that's awesome. So as with all kinds of physics, it looks long, but I imagine this is, making the player character move. This is probably a lot of code and whatnot. So then we have to update the velocity. So we have to calculate the ground velocity, then the fall speed separately. Be sure to go back one tab so the lines are inside the physics process function, but outside the condition we just wrote above. So looking at the new code, for ground velocity, we take the target velocity.x, times it by direction.x, times our speed. Target velocity.z is direction.z times speed. That's our ground velocity. Then we have our vertical velocity. So first we check if we're not on the floor by doing if not is on floor. So if we are in the air, we fall towards the floor, literally gravity as it puts there. And we do this by setting the target velocity y by equal to the target velocity y minus whatever our fall acceleration is times delta. And delta was explained in our last 2D tutorial that's just used to make smooth movements. It calculates how long it took the last frame to run, so then your physics aren't based on frame rate, essentially. And then we move the character by setting velocity equal to target velocity, and we call the move in slide function, which I don't know if that's a built-in function, but never heard of that, but we'll see how that works. So the character body 3D dot is on floor function returns true if the body is collided with the floor in this frame. That's why we apply gravity to the player only when it's in the air. For vertical velocity, we subtract the fall acceleration multiplied by the delta time every frame. This line of code will cause our character to fall in every frame as long as it's not colliding with the floor. The physics engine can detect interactions with walls and the floors or other bodies during a given frame. If movement and collision happens, we will use this property later to code the jump. On the last line, we call character body.move and slide. Okay, that's a function of the character body, I guess, which is a powerful method of the character body that allows you to move a character smoothly. If it hits a wall midway through motion, the engine will try to smooth it out for you. It uses the velocity value native. Internet, I did a speed test and I can see on OBS, it doesn't look like it doesn't look like my connection's bad or anything, but I don't know. I'm gonna blame, but it's happening on both Twitch and YouTube, which is very odd. So I don't even know if this is coming through on Twitch. I mean, I have to select the camera pivot, not the cam. Was I supposed to move the camera pivot or the camera? Oh shoot. Oh, it does say move the camera, and then we move the camera pivot. Negative 45 degrees. Oh, whoa, okay. All right, now we're getting somewhere. This is cool. All right, I'm following. You can run the scene by pressing F6 and press the arrow keys to move the character. Let's see if that actually happens. We'll just select current. Let's see how this works. Okay, we got a scene here. Let's see what happens if I use the arrow keys. Oh man, look at that. We could move diagonally and everything. Heck yeah. What happens if I go off the ground? Do I fall? I do fall. That's awesome. Look at that. We got a working 3D game. Well, not a game, but it's doing something. You see some empty space around the character due to perspective projection. In this game, we're going to use an orthographic projection instead to better frame the gameplay area and make it easier for the player to read distances. So we select the camera again in the inspector, select projection to orthogonal, and in the size to 19. The character should now look flatter, and the ground should fill in the background. Okay. Let's go ahead and do that. Hold on. Okay, so camera. Then over here, is it the projection? Where's here it is. Perspective to orthogonal. Oh geez. Okay. And then size. Got really zoomed into perspective here to 19. Okay. All right. Test your scene. You should be able to move in all 8 directions and not glitch through the floor. Ultimately, we have player movement and the view in place next we work on the monsters. Let's give this another whirl because I'm curious to see how this looks with the new camera. Make this nice and big. Oh, that's awesome. Oh man, that's really cool. Oh man, this is pretty sweet so far. Look at that. Nice. We're getting somewhere. Maybe slowly, but we're on our way. We are on our way to the next step, which is designing the mob scene. I'm gonna take a quick sip of water here. So, in this part, you're going to code the monsters, which we'll call mobs. In the next lesson, we will spawn them randomly around the edge of the playable area. Let's design the monsters themselves in a new scene. The node structures, nodes progress ratio expects 0 is the starter path, end is 1. The path we have set is around the camera's viewport, so any random value between 0 and 1 is a random position along the edges of the viewport. Here's that. We can test the scene by pressing this. You will see mobs spawn and move in a straight line. For now, they bump and slide against one another. When their paths cross, we'll address this in the next part. Let's see if that actually works. I'll be shocked. They do. They just kind of stop. That's funny. Look at that. We got mobs. Oh man. Can I like break this up? No, they're just like, that's like a wall of mobs. That's kind of funny. I could just stop them dead in their tracks. This is a fun game. This is super fun. It's not really a game yet, but you know what? We're getting somewhere, dang it. We are on to jumping and squashing monsters. We have 1, 2, 3, 4, 5 sections left. Already at 3 hours. This is gonna be a 4-hour stream at least. That's okay. I'm having a good time. Hope everybody that's watching is having a good time. And yeah, let's hope we can finish this here relatively directly. I mean, it feels like we got a lot of the hard work done. We got the mobs spawning, the mobs moving, the players moving. We just got to jump and squash the monsters, figure out killing the player, score and replay, character animation, and then maybe we'll skip whatever the going further section is. But we'll see, you know, how we're doing on time and what that all entails. But yeah. Take a quick sip of water. I've been talking a lot here. Jumping and squashing monsters. So in this part, we'll add the ability to jump and squash the monsters. In the next lesson, we'll make the player die when a monster hits them on the ground. So first we have to change a few settings related to physics interaction. Enter the world of physics layers. Oh boy, buckle up. So controlling physics interactions. So physics bodies have access to 2 complementary properties, layers and masks. Layers define on which physics layer an object is. Masks control the layers that a body will listen to and detect. This affects collision detection. When you want 2 bodies to interact, you need at least one to have a mask corresponding to the other. If that's confusing, don't worry. We'll see 3 examples in a second. Okay, that was kind of confusing, but you know what? I'm ready for these 3 examples. So the important point is that you use layers and masks to filter physics interactions, control performance, and remove the need for extra conditions in your code. By default, all physics bodies and areas are set to both layer 1 and mask 1. That means they all collide with each other. Physics layers are represented by a number, but we can give them a name to keep track of what's going on. So let's get into setting a layer's name. Let's give our physics layer a name. Go into project settings, and then in the left hand menu of general, In layer names, there's 3D physics. See a list of layers with a field text next to each of them on the right. You can set their names there. Name the first 3 layers to players, enemies, and world, respectively. Okay, respectively. So let's go ahead and do that. Hop back here, project settings, general, layer name, 3D physics. Layer 1 will be player. Layer 2 will be enemies. And layer 3 will be world. Cool. Now we can assign them to our physics nodes. Where are we? Okay. So assigning layers and masks. So in the main scene, select the ground node in the inspector, expand the collision section. There you can see the node's layers and masks as a grid of buttons. The ground is part of the world, so we want it to be part of the 3rd layer. Click the lit button to toggle off the 1st layer and toggle on the 3rd, then toggle, but that's what I'm doing. And then we add the squash function, which literally just emits the squash signal and then does the queue free, which just, yeah, deletes the mob essentially. Whew. I need a quick break after that. My goodness. Okay, so we use the signal to add points to the score in the next lesson. With that, you should be able to kill monsters by jumping on them. You could press to test it and set main as this project's main. However, the player won't die yet. We'll work on that in the next part. Okay, let's see if this works. I'm very curious. Player shouldn't die yet. Good. So let's see if we can see if I can actually can I squash one, please? These guys are hard to hit. Maybe I did mess it up. I can't land on a single one. Give me an easy one. Okay, I think something's messed up because I'm not bouncing. I feel like I'm landing on them pretty good. Uh-oh, we got a bug. Oh no. Something's not working. I'm definitely hitting some. None's being squashed. Okay. Let me try one thing because I wasn't sure about this. Let me try doing move and slide first and then doing this after. I don't think that's the case. I think it has something to do with incorrect layers or masks, but let me see if this fixes it because I'm not sure if that's what I should be doing or not. Okay. I don't know if this is making a difference or not. Uh-oh. Oh no, we're gonna have to troubleshoot here. Nothing's happening. Okay. Troubleshooting time. Okay. Squash is defined. Function squash, it just emits. Squash runs here. The mob is grabbed from the collision. Let me go back and make sure I feel like some of my masks or players aren't right. So this collides with enemies and the world. It's on layer 1. This is mask 3 for the world, no collisions. Mob is layer 2. And that shouldn't be with anybody, right? Let me double check. Player is good. The mob only has layer 2. Okay, is there like console.log? Is there some sort of debug.log? Like a debug? Print debug, is that what I want? Let me see if this works. Hold on. Uh-huh. Okay. So print debug does kind of do what I thought. Kind of. So what we want is then collisions. We want to see if we get past this. I mean, I straight up copied the code, so I don't think I have a typo anywhere, but I think that's why I'm more thinking it has something to do with the masks, but I already checked that. Is the player supposed to collide with the world? It is. It says mask to enemies in world. That doesn't feel right though. Like, why would we need a mask with the world? Oh, I guess for the is. What? I'm I don't know. I'm sorry, everybody. I don't know what's going on with these technical issues. I might just have to call it a bit early here tonight and really just, I don't know, look at my settings, see what's going on, see if I can figure out what this is, and hopefully have it fixed for next week. Yeah, I guess we'll call it early. But yeah, thank you so much for watching. If you enjoyed, a like is always greatly appreciated. And until now, shutting down the system. Have a good week, everybody.